Okay, so let's scoot on. We're talking about complex zeros and the fundamental theorem of algebra. Well, the fundamental theorem of algebra states one thing very simply. If you have a polynomial whose degree is greater than or equal to 1, you have at least one complex zero. Okay? So, let's take a look at number 1 here. They're asking us to find a polynomial with the given zeros. So they've given me these 4 zeros, correct? Okay. But well, let me back up a second. Since they've given me these 4 zeros, then I would believe that the degree of the polynomial I'm looking for has a degree of 4. Because there are 4 zeros, so the degree should be 4. Yes? Okay. However, there's one thing that we need to remember. Complex numbers, when you see one complex number as an answer, well, I guess the question is, do you ever see one complex number as an answer? No. Complex numbers never travel alone. Complex numbers always travel in pairs. So if you see a positive I as an answer, then you will also see a negative I as an answer, which means in this case I have 5 zeros, which means I have a degree of 5 for the polynomial. Now, this problem becomes something like we did in the previous lecture. These are all our zeros, which means x is going to be equal to 0, and it's going to be equal to 1, as well as 2, it's equal to I, and it's equal to negative I, isn't it? Okay, so remember what we did, right? We're working backwards. X equals 0, there's not much I can do with it. But this x equaling 1 didn't come from the factor of x minus 1? And this x equaling 2, didn't it come from the factor of x minus 2? And x equaling I, didn't it come from the factor of x minus I? And lastly, didn't this one come from x plus I? And then this x equals 0. Yeah, that just came from x, didn't it? 5 zeros, 5 factors. And now we get to multiply them all together. So, some of you are like, oh my gosh, I don't want to do this. Hang in there. We got to work smart, not hard. So here's my recommendation. I personally am going to multiply these 2 factors together, and I'm going to multiply these 2 factors together. Okay? My little x is going to hang out there waiting for me to recognize it. So when I multiply the first 2 together, hopefully you agree with me. And when I multiply these last 2 together, hopefully you agree with this result. So take some time, work it out, make sure you agree. And then I'm going to multiply even more. And I shall multiply the 2 parentheses together. This x at the end, it can wait. So, looks like we have x times a quantity. We have an x to the 4th, right? Minus 3x to the 3rd, correct? Minus 3x. You know what? I'm going to start that over again. Why? Because I took my multiplication out of the order I'm used to taking it in. So I'm going to start it over again. This is what we do sometimes. Okay, so I have x to the 4th plus x squared. That's the order I like to do it. Minus 3x to the 3rd minus 3x plus 2x squared, and then plus 2. Whichever way you distribute, you're going to get the same results. And then I am going to collect my like terms. X to the 4th is the only x to the 4th. Minus 3x to the 3rd is the only x to the 3rd. I have a 1x squared and a positive 2x squared. So that looks like a positive 3x squared. Looks like I have a minus 3x. And then a positive 2. And then last but not least, that solo x is going to get distributed through. And when it gets distributed through, here is my 5th degree polynomial. Cool? All right. So the key here is understanding that complex numbers travel in pairs. So let's look at number 2. I have 2 zeros, right? So I should come up with a 2nd degree polynomial, right? Yeah, no, because complex numbers travel in pairs. If you have 2 plus I, that's right, you're going to have 2 minus I. This guy right here, as well as this one over here, this is known as the conjugate. The conjugate means the real number stays the same sign. The imaginary number switches signs on me. Okay? So now I get to approach it like I approach this one. I am going to get x equaling 3, x equaling 2 plus I, and then x equaling 2 minus I. Yes? This first one came from an x minus 3. The second one came from, that's right, minus the 2 over, minus the I over. And the last one came from, that's right, minus the 2 over, add the I. Cool? Okay, now you're like, well, now what do I multiply? I personally multiply the parentheses with the i's in them, because just like over here, when you multiply the parentheses with the i's canceled. And they should cancel. They better cancel, otherwise we've done something wrong. So I'm going to leave this as x minus 3. So here we go. And yes, there's another way I can look at this to make my distribution simpler, but I'm just going to do the long distribution to make sure we're all on the same page. So I have an x squared, I have a minus 2x, and I have a plus ix. I have minus 2x plus 4 minus 2I. And let's distribute this I. I have a minus ix, a positive 2I, and a negative I times a negative I is, that's right, a negative I squared. And now I'm going to collect my like terms. So I have an x squared, a minus 4x. These ix's cancel, don't they? I have a plus 4. These two i's cancel. And now I have a minus I squared. Okay, so we have to remember, I is equal to, good, square root of negative 1. So I to the power of 2 is equal to negative 1. If you have a negative in front of a negative 1, what does that make it? Yeah, that makes this I squared, a minus I squared, into a plus 1. Which means we have x minus 3 times the quantity of x squared minus 4x plus 5. Are we done? Nope, not done. Then you get to distribute these two parentheses together to get your third degree polynomial. And you know what? I'm going to let you finish that one off. The key here is complex numbers travel in pairs. If a positive I is an answer, so is a negative I. If a 2 plus I is an answer, well, so is 2 minus I. The conjugates are always part of the solution, even if they didn't write them. We need to write them so we know how many solutions there really are. So we know how many zeros there really are. Cool? Okay, hang in there. I got some problems for us to solve. Okay, so let's look at these directions. Use the given 0 to find the remaining solutions. So I have a fourth degree polynomial and they're asking me to find the solutions. How many solutions should I have? Good, I should have 4 solutions. Now, here's the difference between this fourth degree polynomial that we're supposed to solve and one we did in a previous lecture. In a previous lecture, they never gave us a starting point. We had to find our own starting point by finding those P's and Q's. In this particular situation, they gave me a starting point. They said that one of my zeros is negative 2i. Are you with me? So this is good. They gave me something to work with. Now here's the cool thing. I am going to solve this like we did in that previous lecture. I am going to use synthetic division to make certain that I can take this fourth degree polynomial down to a third degree polynomial. So I know I'm going to have negative 2i here because that's a given 0. So I'm going to use it. I have this fourth degree polynomial. Did we skip any x's? Nope, we go from a 4 to a 3 to a 2 to a 1 to none. So that's good. I don't need to put a 0 in its place. Okay? Remember, that first number always comes down. That's how we start, right? So here we go. So 2 times negative 2i. Yeah, that's negative 4i. So I have 5 minus 4i, don't I? Okay, well that's lovely. And now I have to take 5 minus 4i and multiply by negative 2i, don't I? Okay, I got some side work to do over here, so I'm going to write this down. So I have negative 2i times 5 minus 4i. So you're going to have to remember how to multiply complex numbers. So we have negative 10i, right? Plus 8i to the power of 2. Remember what we said just a few minutes ago? What's I squared equal to? Good. It said it was equal to a negative 1. Which means I have actually negative 8 minus 10i. Okay? We have negative 8 minus 10i. Cool? Okay, well that's going to go under this 5. Negative 8 minus 10i. And when I add those together, that's right. And I'm going to give myself a little bit more room in between these numbers because I have a feeling I'm going to need a little bit more room. So the 20 and then that negative 12. That gives me a negative 3 minus 10i, doesn't it? Okay, so I have to take this negative 3 minus 10i, and I get to multiply it by this negative 2i, don't I? All right, let's multiply. Looks like we get 6i plus 20i squared. But remember what I squared equals to. Yeah, I squared is equal to a negative 1, which means I have negative 20 plus 6i. So negative 20 plus 6i. Ooh, the 20s cancel. That's cool. So I just got 6i. And now I got to do 6i times 2i, negative 2i. What is that? Yeah, that's a negative 12i squared. But what's I squared equal to? Negative 1, which is going to make this guy a positive 12. And looky there. What's your remainder? That's right, the remainder is 0. Woohoo! Well, that's good, right? Because it was supposed to be a 0, which means I better have gotten a 0 as a remainder. Agreed? Okay, now, I'm going to need a little bit of board space here, so I'm going to erase my side work. And as I erase my side work, let's talk. So that's one solution, which we already knew. But don't don't we know a second solution? Yeah, we know a second 0, don't we? If one of the zeros is a negative 2i, what's another 0? Yeah, another 0 is a positive 2i, isn't it? Because complex numbers travel in, that's right, they travel in pairs. So, one of my other zeros is a positive 2i. Remember, this was a 4th degree. We cut it down by 1 degree, so this is a 3rd degree. So I'm going to take this 3rd degree, and I am going to divide it by a positive 2i. Remember, that first number always comes down. And you're like, oh my gosh, all that work again. Well, you know, here's the cool thing. If we did the first one right, which we did, the second one actually is a whole lot simpler. So watch. So what's 2 times 2i? 4i. Oh, look. The 4i's cancel. Leaves me 5. What's 5 times 2i? Yeah, 10i. Look, the 10i's cancel. Leave me negative 3. Puts a negative 6i here. Woo! That was easy. That was nice and simple. So question, what degree is this polynomial? Yep, that polynomial is a second degree polynomial. So now I am trying to solve a second degree polynomial to find my last two answers. So some of you may use the quadratic formula. I think this thing will factor, so I'm going to factor it. Follow along. And I'm doing my factoring a little bit different than how some of you guys learned. You guys learned to use that magic X thing, so use it. Okay, so that works. I end up with x equaling 1/2 and x equaling -3. So my last three solutions are 2i, +1/2, and -3. Cool? Okay, so hang in there. I got another example. Okay, so let's look at this problem. They gave me another fourth degree polynomial. They gave me one of the zeros, so I actually have a starting point. They told me the 0 was 3 minus 2i. So I'm going to set up my synthetic division problem right here. Gratefully, there's no missing x's. So 3 minus 2i is what I'm dividing by, and I always bring down that first term to 1, don't I? Okay, time to start multiplying. Now on this problem, just like the last one, you have to be careful because you're multiplying complex numbers, right? So you have to be careful. Get some scratch paper, take your time. So 1 times 3 minus 2i is 3 minus 2i. I combine these guys together, I'll get a -6 minus 2i, correct? Okay, and now I'm supposed to multiply, and here's where you have to be careful. Here's where your scratch paper comes in. Here's where some work is going to come in. You have to take the 3 minus 2i, and you need to multiply it by that -6 minus 2i, don't you? Okay, let's take a look at this. -18 minus 6i plus 12i plus 4i squared, correct? Okay, so -18 plus 6i, I squared is a -1, isn't it? So this plus 4i squared becomes a -4, doesn't it? So that gives us a -22 plus 6i. So, -22 plus 6i. Combine these together, you get -1 plus 6i, don't you? And now you have to multiply this 3 minus 2i times the -1 plus 6i, don't you? Okay, let's take our time. So we get a -3 plus 18i plus 2i minus 12i squared, right? So I get to combine those i's in the middle, and I squared is, good, -1. So this -12i squared becomes, good, +12, which gives me 9 plus 20i. So 9 plus 20i. Well, that looks like it is 30 plus 20i, doesn't it? Okay, I got one more multiplication to do. I have this 3 minus 2i times the 30 plus 20i, don't I? Okay, take your time. Looks like that's 90 plus 60i. Ooh, minus 60i, that's a good sign. And minus 40i squared. So these guys in the middle drop out, don't they? So I have 90 minus 40i squared. What's I squared? Yep, -1, which means I end up with 90 plus 40, which is 130, isn't it? Oh my gosh, this totally worked out. That's a positive 130. I get a remainder of 0. So yay! That's what was supposed to happen. I was supposed to get a remainder of 0 because this 3 minus 2i was a 0, wasn't it? And you're like, well, that's fine. Where does this get me? This is a 4th degree polynomial. You're supposed to have how many answers? Yes, 4 of them. They gave you one solution, didn't they? But, don't you know a second answer? Yes, you do. Because complex numbers travel in pairs. So, that's the awesome thing. So since I know one solution was 3 minus 2i, what's the second solution? That's right, I heard you. 3 plus 2i. So I'm going to do my synthetic division again, but now I am going to use, by the way, what degree is this polynomial? If this was a 4th, and you divided it by a single, this is a 3rd. So I'm going to take this 3rd degree polynomial and divide it by 3 plus 2i. And you're like, oh my gosh, Remember what happened on the last problem? That second go around was quick because the i's all dropped out, right? I bring down this 1. Okay, what's 1 times 3 plus 2i? 3 plus 2i. Oh look, the 2i's canceled. That leaves me a negative 3, doesn't it? Negative 3 times 3 plus 2i. Yep, negative 9 minus 6i, right? Oh look, the 6i's dropped. Leaves me negative 10, doesn't it? Negative 10 times 3 plus 2i, right? That's a negative 30 minus 20i. Looky there. Remainder of 0. Woohoo! Loving it. See how quick that dropped out? If we've done everything correctly on the first one, the second one is easy peasy. So, what degree is this guy? Remember, this was a 4th divided by 1, so this answer was a 3rd. Divided it by a 1st degree, so this answer is a 2nd degree. Good. So I am solving a 2nd degree equation. And my 2nd degree equation I am solving is x squared minus 3x minus 10 equaling 0. Does it look like it factors? I think so. Looks like we have... Good, because that gives me the negative 3x. There we go. So it looks like our last two answers are a positive 5 and a negative 2, aren't they? Okay, so we have 4 solutions. We have 4 zeros. They gave me 1 0 of 3 minus 2i. We remembered that complex numbers travel in pairs, so there is our second 0. And we got to solve the 2nd degree polynomial, which gave me the last 2 solutions. Cool? Okay. Hopefully this made some sense. It's a little bit of a review or refresher from the last section when we had to do synthetic division. You have fun with this stuff, and I'll catch you on the flip side.